I'm now going to convert this eye setup into an HDA, which will make this a little bit more portable, and it'll make it easier to use as part of a character. I'll right click on the subnetwork for the eyes, and select Create Digital Asset. I'll give this the asset label eyes. I can then rename this. I'll then create the HDA. I'll change the HDA icon to be shelf lookup. I'll give this 3 inputs and 3 outputs. I'll then rename these. The first input will be the deformable mesh. This will be the geometry of my character. I could call this mesh, but deformable mesh has a meaning within my character rig. The second input will be the skeleton. The third input will be the controls. The outputs will be the deformable mesh, the skeleton, and the controls. I can apply to save the changes to the HDA, and I can accept. I can now re-enter the node, and I'll color the outputs. We can also rename our outputs. We'll have outputs for my controls, my skeleton, and my mesh. I will attach the blast node to the skeleton. This node is for the future and it's not something which I'll use yet. Essentially, some geometry may already have eyes attached, and in this case I would be replacing those eyes, so I'd be using the blast node to delete them. This proxy mesh, however, has no eyes, so I will not be implementing this at all yet. I'll add a merge node after this blast node. This is where I'm going to join the eyes with the rig, and I'll get an object merge node so that I can do this. I'm going to use this object merge node to reference my eyes, so I'll need to reference the null at the end of my eye network. I'll rename this null to eyes out. I now set this as the path of my object merge node. There are some attribute mismatches here which I will want to fix eventually, but I can leave those for the moment as they're not really relevant yet. Next, I'm going to create a null, and I'm going to connect it to the input branch for my skeleton. I'll rename this null to skeleton in. I can then reference the skeleton for my rig. I'll add an object merge node for the eye network, and this will reference my skeleton in node as the path. I will then want to switch between this external skeleton and the default skeleton which I've created for the eyes. I'll do this with the switch node. I'll connect the switch to the skeleton for the default rig, and this will drive the second input of the point VOP nodes. The switch node will then be set by the default rig for the eyes, as well as the object merge node which is now referencing my skeleton, and I can now use this to switch between the inputs. I should now be able to use the switch. Because my name for the rig skeleton and the eye skeleton are the same, the eye should now be matched up with the skeleton. So this will update the basic setup, and I now want to work on my parameters. I'll open the type properties for the HDA. First I'll use the iris value, and this is the value which I'm using to control my carve node. This was created as a temporary parameter which is stored on a null. I can add this manually, or I can connect this from the null. I can rename this parameter to cornea. I can now update the expressions in the carve nodes to use the HDA parameter instead of the parameter on the null. I'll need to do this for all of the carve nodes. This will give me control over the diameter of the iris and cornea. Next, I want to have control over the bulge of the cornea, and I'll get this from the poly extrude node. Here I'm going to add the distance value to my interface, and I'll call this value corneal bulge. I can also add the smoothing value for the cornea, and I'll do this with the strength value from the smooth node. I'll give this parameter the name cornea smooth. For the moment, I'll add the blend shape value for the pupil. I have not yet set up the blend shapes for export, and I should probably do that instead, but the pupil dilation does help with the customization for the eyes. So I'll add the blend parameter, and I'll rename this parameter to pupil dilation. Next, I can add my switch to the interface. I'll drag the select input parameter onto my parameter interface. I'll rename this parameter to use skeleton. I'll then change the parameter type to be a toggle. Currently, the mesh will be displayed by default, and this is the behavior that I want. I do, however, want to be able to visualize the other inputs easily, so I'm going to create a parameter to do this, and this will be an ordered menu. I'll name this parameter display. The callback script will be who.pwd, as this will be referencing this current node. I'll then call the setOutputForViewFlag method. I'm going to set this with the Quarks dictionary. This will give us information from this node. The information that I'll want is the current parameter, and I'll get this with the key palm. This will give me the parameter. However, what I actually want here is the value for this parameter. So I'll call the eval method on the Quarks dictionary. I will now create the menu for this, so I'll work in the menu tab. The first item will be for the mesh, and this will have a token value of 0. And for some reason here, I put them in the wrong way around, as the label should be the second value. After the mesh, we'll have the skeleton, and this will have a token value of 1. I will also want a third value for the controls, and this will be 2. Next, I want to set up my controls so that they can be manipulated within the viewport. This will allow me to manipulate the default rig for the eyes from the HDA level. To do this, I'll work in the Node tab, and I'm going to set the default state. The default state will now be KineFX __ rig pose, and this is essentially the same viewer state as the rig pose node. I can apply it to save my changes. I'll exit to the HDA level. If I select the HDA and press enter in the viewport, I should now have the ability to manipulate my rig. My menu is incorrect here, and I'll fix my ordering for the menu. I should now be able to specify which outputs we display for this rig. I can also now specify whether I'm going to use the input skeleton or if I'm going to use the default mesh. I am going to update my defaults here, so open the type properties. I'm going to work in the channels tab, and I'll be updating the use skeleton parameter. I'll set this to be 0 by default. I'll also check the default formalized display. This should be 0 by default, although I could also consider setting the default of 1 here. Finally, I want to give a bit more control on the movement of the eyes. I want to be able to manipulate the eyes asymmetrically, which is what I currently have, but I also want to be able to manipulate the eyes symmetrically. We can treat most characters as having symmetrical eyes, even though most people do not have perfectly symmetrical eyes. This means that I will need to update the rig for the eyes. I'll begin with the add node, and we're now only going to be creating a single eye, so I can remove the third point from the add node. Next, I'll update the name node, and here I'll remove the third name. So in this case, I'll only be generating a left eye. I'll make some space here, and then I'm going to mirror the skeleton joints using the mirror skeleton node. I'll need to configure the skeleton mirror node. We're going to be mirroring around the head, so we do not actually need to mirror the head joints. So I'll exclude this from my mirror group. This will be done with caret @name is equal to head. Next, I'll update the naming. The find token will be left, and we'll replace this with right. This will give us our mirror joint, and it will also rename the mirror joint. Currently, these are mirrored around the x-axis, but I want these to be mirrored around the head. To do this, I'll change the reflect using parameter, and I'm going to reflect using point, and the reference point will be the head. In order to have symmetry and asymmetry, I'm going to work with 2 rig pose nodes instead of 1. I'll connect these before I update the transforms. I'll then duplicate the skeleton mirror node, and that will be connected after the second rig pose node. So I'll have 2 branches, and these branches will be connected in the opposite way, with one branch having the rig pose before the skeleton mirror node, and the other having the rig pose placed after the skeleton mirror node. The branch where the eyes are mirrored before the rig pose will give us an asymmetrical rig. The branch where the pose is mirrored after the rig pose will give us a symmetrical rig. I'll connect these 2 branches with a switch node. This switch will allow us to switch between an asymmetrical rig and a symmetrical rig. I'll move the correction for the transforms after the switch node. I want to create a second correction before my final correction, and this is because I'm using the mirror nodes, which is mirroring the transforms. I'll do this by duplicating my existing network, and I'll place it before the first correction. In the getPoint transform node, I want to specify that this will only apply for the right eye. So the group will be @name is equal to right *I, and this will find any joint with right in the name. In this case, I will not perform any rotations, as that is actually an overcomplicated way of doing this, and instead I'm just going to manipulate the transforms directly. In this case, the mirroring will convert the transform from a right-handed transform to a left-handed transform. To convert this back, all I need to do is negate the x-axis, so the transforms will be converted into vectors. These will be passed through directly apart from the x-axis, where I'll connect a negate node. This should correct my transforms, which will make the transforms match up with the skeletons for the rigs which I'm creating. I can double check my final output, and the output is giving me correct transforms for the eyes. So I have my transform set up, but the controls still need some work. Currently we will have some overlapping controls, We will have left side controls for the asymmetrical as well as the symmetrical, and we do not really want this. To compensate for this, I want the symmetrical network to drive the asymmetrical network. I'll do this with the rig attribute VOP. This will be connected after the skeleton mirror node in my asymmetrical network. The second input for the network will then be set by the rig post node for the symmetrical branch. I will now have the symmetrical network only setting the left-hand side of the character, and the asymmetrical side of the network will only control the right-hand side of the character. This means that I can hide all the left side joints in the asymmetrical pose node. To do this, I'll open the settings tab and I'll add a configuration. This will be not at name is equal to right, and I'll hide everything that is not a joint with right in the name. So this will give me the right joint, but it will actually remove a little bit of the control that I have over the display of the joint. So I'm going to use two display operations. I'll add a configuration before this configuration. This configuration will set everything. However, I'm not going to hide everything here. I want to retain the lines for visualization. So in this case, I can hide the joints. If I had control geometry attached, I would have to hide that as well. But in this case, hiding the joints should be fine. I can then remove the exclamation mark from the second operation. So this will now specify the right-hand side of the rig. And here I will display everything. This will give me display of the right-hand controls only, but it will allow me to retain the skeleton so I can see both the left-hand side and the right-hand side. I will also need to update the display for the symmetrical part of the rig. I'm going to manipulate this with the left-hand side of the rig. I'll be working in the settings tab and I'll add a configuration where I'll hide everything. I can then add a second configuration. Here I'll specify all of the left joints with @name is equal to left asterisk. This will give us a symmetrical rig and an asymmetrical rig, which we can specify within the switch node. These controls should now be added to the HDA. So I'll open the type properties. I'll select the switch for the symmetry and I'll drag select input onto my parameters. The name will be symmetry. The label will be symmetry. I'll then work in the menu tab. And somehow I managed to set this up incorrectly again, where I set the token and the label the wrong way around. The first item should be asymmetry with a token of 0, and the second item should be symmetry with a token of 1. I will of course need to correct this. I now have a menu option for symmetry and asymmetry. However, when I use a symmetrical joint, my right-hand joint will still be shown, and for the symmetrical controls, the right-hand side should never show. The left-hand display should be working correctly, as we should only be displaying the left-hand side here. The right-hand side of the display, however, should not show when we're working with the symmetrical rig. I'll open my parameter menu, and I'll copy the symmetry parameter. I'll then paste the relative reference on the show joints parameter, as well as the show polygon lines parameter. I then want to edit these expressions, as these expressions will be the opposite of what I currently need. I'll precede the expressions with an exclamation mark, and this will negate them. Now when we have symmetry, the right-hand side of the rig should no longer show at all, and the asymmetry setup will give us a fully asymmetrical display. This is working for the most part, apart from with the asymmetry. Here my left-hand side of the rig should match the symmetrical side, but it currently doesn't. There's a couple of reasons for this. The first is that there's still pose values for the left-hand side in the rig pose node. I'll need to remove these. The second is that I haven't actually set up my rig attribute VOP yet, so we're not influencing our asymmetrical joints with our symmetrical joint setup. So I can now work on my VOP, and I'll need a get point transforms node. I will also want a set point transforms node. These will be connected directly to each other. So the points will set the points, the transforms will set the transforms, and the local transforms will set the local transforms. I'll get the transforms from my second input. I'll specify two joints within the get point transforms node. The first will be @name is equal to head, and the second will be @name is equal to left asterisk. This should make sure that these joints have the same transforms as our symmetrical transforms, as we're just replacing the transforms in this branch. I have, however, made a mistake within the symmetrical network, as currently we cannot edit the head joint, so I'll need to work on the visualizations within my rig pose node. In the second visualization, I'll specify @name is equal to left asterisk and @name is equal to head, although we could technically get away without any visualizations here. So I should now have two options for manipulating these joints. I can either have a symmetrical setup or an asymmetrical setup. We should also be able to override this entirely and use an existing skeleton. We should also have the ability to see the incoming geometry. and this should give me the initial HDA for my eye setup, apart from one final problem, and this problem relates to the viewer state when this HDA is locked. When the HDA is locked, we will not be able to manipulate our rig in the viewport, and to fix this we are going to need to expose all of the transforms within our pose nodes. So I'll open the type properties again. I will make some other temporary adjustments. For example, I have the blast node here, but I'll bypass this for the moment, as I haven't yet set this up to work correctly. Now what I'll need to do is update my rig pose node so that everything connects correctly with the interface. I'll set all of the parameters to the default values, as I do not want to set incorrect default parameters when I drag these onto the interface. I'll need to do this for both the symmetrical node and the asymmetrical node. I will not be using the scaling parameter within this rig, so I'll lock that parameter. To manipulate the size, I will eventually expose parameters like the circle size. It is generally better to use the geometry to perform these kinds of actions, especially when the deformation is being performed by rig. I will want to separate the transforms from the main controls for the rig, and to do this I'll add a folder to the interface. This folder will be called Transforms. I'll set this to be a simple folder. I can then add the parameters to this folder. I'm going to be adding both the translation and the rotation, and I'll begin with the head parameters, and this will be followed by the parameters for my left eye. These can then be renamed, and first I'll have my head translation. This will be followed by my head rotation. I'll then have my left translation. This will have the label left translation. This will be followed by the left rotation, which will be labeled left rotation. I'll do the same for the controls for the right eye. We will have the right translation and the right rotation. I can save my changes, and then I can match the definition, and this should lock us to the current HDA definition. With the node locked, we can still now manipulate our transforms, and we can manipulate our controls in the viewport. So that will give us the HDA for the eyes, and we'll now have a far more portable interface. This is still very basic, and we can still make a lot of changes to this, but it will give me the basics for an eye system which I can use for multiple characters.